Okay, hey, grade eights, it's Mr. Smith here again. Last video I'm going to be doing for, well, maybe not today, maybe I'll do one later, but um, it'll be the last video before class I do today. So I don't have to buy you DQ mini blizzards because I made that promise. I didn't want to forget it to help you this week. Last question is from page, I think this is still page 386. If it's not, it should be 387 then. But anyways, it's question 17. It was in your homework, okay? If you don't believe me, here is the slides. All right, so Math 8, Week 4, April 29, May 6, 2020. We're reviewing and solving word problems. Go through the Google slide, do the homework, do the portfolio. This week's learning objective. Well, we're just doing more word problems. I hope you watch some videos and you're not totally relying on me. This is where I made the promise to do videos. Here it is, 12:15, and I should have no problems making this deadline. By the way, some of these middle names are fake, just so you know. Anyways, here's your homework. So I did question 13. Okay, I'm basically spending today doing these three questions, and I already did questions 13, and I already did 15. So now I'm doing question 17. All right. So that's where we're at. Now, of course, again, I do my own little fake questions. And sorry, I got a little disoriented here because my thing's off the screen. All right, I guess it doesn't want me anymore. Just gonna pause here for a sec. All right, so you see that my little head has disappeared. Something goes wonkadoodle with the dual monitors, so whatever. It's not like you need much to see my face, grade 8s. Anyways, let's get to it. A peregrine falcon is hunting a bird in flight. The falcon begins its descent from 129 meters. The hawk reaches its prey at a height of, a height of 22 meters. Okay, so bird is up here. No, I'm not going to even try to do a bird, but let's try and do a bird. Hey, that's not bad. So it starts up here at 129 meters. And just like falcons and a lot of raptors want to do, they spawn something and then they go down. By the way, what strategy am I using here? I'm drawing a diagram. Can you draw a diagram? Yeah, you can. I am not talented in drawing. I spent my youth doing a little bit more music. So if I can put up with myself in my drawings, you can too. So down here at 22 meters, all right? All right, so it drops, right? And these are phenomenal birds, by the way. I guess they can go over 100 kilometers per hour when they do a little free fall thing. Anyways, the situation can be modeled using the formula of, oh, look, I recognize 129. There's my 22. And then there's 15t, where t represents, so again, this is a question where they give you the formula. You do not have to make it up like you did for question 15, where t represents the time in seconds. What do you think the value of t represents? Well, remember, the 15, let's just talk about it over here. So 15t. Well, first of all, this is a multiplication relationship. Okay, I'm not going to spell it all that word because I'll run out of room. This usually means, let me just talk a little bit about English. Per 15 per t. 15, and it says here, t represents the time in seconds, So there's something that's going on here, 15 per second. 15 what? 15 per second. 15 per second. Well, we're talking about going a distance, right? There's a change in distance. There's a change in altitude, right? This bird was flying at 129, went down to just 22. So 15 per second. And by the way, another word for per, some students prefer this word, but it's not really a big deal. Each, okay? I just didn't like the way I wrote that. Per is equal to the word each. So for each second, something is happening with 15. What are you thinking? I'm going to count to about 7 or 8 in my head here. You can pause the video, doesn't matter. So I think we're talking about a speed, okay? Because it sounds like this bird is traveling at 15 meters per second, right? So the 15 represents the distance this bird, the distance the falcon travels 15 meters, the distance in meters, just to put a little brackets here, in meters, the distance the falcon travels in 1 second, or you could say per second, or each second, okay? So a little teaching moment about, remember this forward slash, right? 15, we would write it like this, 15 meters per second. That's literally no different from kilometers per hour, except the unit difference. But I'm saying there's no difference in the relationship. So you can go with smaller units, meters per second. Meters is a smaller unit than kilometers. Second is obviously a smaller unit than hours. Or you can talk about kilometers per hour. But the word per, the word each, when you see the word per, right? Or when you see the word each, you're kind of talking about a rate of some sort. Now, rate can mean it can mean speed, but it can also mean something else, right? What if I spend $20 per day, or more real life, $6 per day on my latte? All right, that is a measure of speed. Okay, it may not be meters per second or kilometers per hour, but it is a type of rate. It's dollars per day, meters per second, / per and each. Okay, I think I've beat that horse to death a little bit. It's a phrase from my farming grandparents, beat that horse to death. I would never beat a horse to death. Okay, animal activists, get off my back. 129 is equal to 22. I insist on making this equal sign good. I don't know why my pen is so crazy. Equals 22 plus 15t. All right, now we really delved into that question. It's the distance traveled. Distance traveled per second. Per second. Okay, so in other words, it's the speed. All right, so now we're on to question B. All right. After how many seconds does the falcon reach its prey? Give your answer to the nearest tenth. Okay, little instructions on how to round. So let's solve this. Okay, so again, what do we have here? I'll now switch colors. Let's go back to red. Okay, we have this constant. We have this coefficient. Coefficients always attached to a variable. Doesn't matter if it's t, x, a, whatever, m, n, g, k, z. 15t, this is a coefficient. We deal with it last. Here's our bed mass again. Okay, you notice how I like to write the d and the m and the a and the s together. So, Mr. Smith, when it's written like this, because I know some of you are saying, I'm going to go down here. Mr. Smith, I prefer if it were written this way. And I'm saying to you, it doesn't matter. Okay? Whether they put this part first and this part second, or this part first and this part second, doesn't matter. You still deal with the constant first. Don't get too focused on the location or the way, the style in which the question is written. All right? Don't get hung up about that. This is still a constant. Just because it's listed first in our equation doesn't change a darn thing. Okay? So you still zero this out. All right? So bye-bye 22. And of course, the only rule in algebra, or certainly the most important rule by a country mile is whatever you do to one side. I was waiting to see if you filled that in. You do to the other side. So 129, minus 22 is equal to 7, right? 9 minus 2 is 7. 12 minus 2 is equal to 10. So 107 is equal to 15t. All right. So 15t, there's my wackadoodle equal sign again, equals 15t. 107. What are we going to do to both sides to get rid of that 15? Now we're saying, I don't want to solve for 15t. I want to solve for 1t. I got to do something with this 15. 15 multiplied to t. What's the opposite of multiply? Divide. Divide both sides. Divide both sides. Okay. So 15, that reduces to a 1t. A 1t, but we leave those ones invisible. They don't have to be written. We've solved just for t. So this is a happy moment. I don't even care what's happening over here on the left. This is a happy moment for me, except I can't draw a happy face. This is a happy moment for me. I'm yay. I'm going yay because I got t by itself. I've isolated. That's the magic word you'll hear from high school teachers and college and university teachers or professors. You've isolated the variable. Well done. Caramel candy bar for you. All right. You've got the t by itself. So now we've got to figure out what 107 is. Hey, you know what I'm going to do? I'm just going to show you again once more that you can go to Google and just use it as a calculator. And it says 7.1333333333333. All right. So we know what to do. We got to round, and it says to the 10th. So right there, right where I drop my cursor. Now the 3 isn't going to affect or bother the 1, so now we go back to our page, and I'll just make this over here. So 7.1. Again, 7.1? Yeah, 7.1. So that's our answer. 7.1, and what do we need for a unit? It's time in seconds. So if you want to write a statement out at this point, let's just get purple. Let's make it a little bit bigger. Okay, just drag it a little bit more. All right. So how many seconds does a falcon reach his prey? Well, you could just say that after 7.1 seconds, the falcon reached its prey. Reached its prey. Okay? That's the answer. That's the answer right here. All right? Okay, well, I hope that helps. Two of these questions, you were given the formula. The middle question, you had to find the formula. Look, there's my face again. Isn't that nice? No. Let's put it down here where it belongs. No, let's put it over here. What did I want to say? Oh, yeah, we had to build the equation here for question 15. These questions, these questions. Do you know what I'm pointing at? I'm pointing at question 15. Look, I'll just take this, and I'll make this, and I'll do this. Make it super big. These questions are the ones you want to practice the most because they force you to build the equation by yourself. You have to analyze the language. You have to analyze the words. You have to translate the English into math. And you can do it. I have faith. My students are brilliant. Okay? You know what I'm saying? Schreiner's students aren't. Boom. I'm kidding. See you later, guys. I'm kidding.